Jai Hind everyone. So in today's lecture, we will be going to learn about disk scheduling, various disk scheduling algorithms and operating system. So first of all, before moving to the various algorithms, we should know about how disk can be, move. What is the mechanism behind the disk? So when we talk about a disk in your operating system, so here you can see your operating system consists of a disk which is having a platter. So this is you can say it is a kind of a flat surface which is known as a platter, and there is a spindle around it that is used for the rotation. So the platter moves around this spindle in a cylindrical form. So on this platter you will be having various kinds of sectors. So the sectors here is this particular area. So this is your sector here, this one. So what happens is when your disk revolves, then when your disk rotates, when that particular platter rotates, so every sector needs to be tracked down. So this particular sectors again have various tracks into it. So consider if you are having this kind of a track. Now what are the tracks inside it? These are the tracks from this side to this side. So these are the particular, you can say, storage elements in which the data is being stored. So you can say this is like the data is stored among platter number 8, like it will be on platter number 8 and sector number 4 and the track number. So track number will be on sector number 4 because this is again another track, this is again another sector. So consider this is sector 3, this is sector 4, this is sector 5. So on sector 4, at which track? So this is your track left and track right. So your data would be going to stored upon which number of track. So this is the particular head mechanism in which your disk rotates. Your you can say you can access your data on your disk. Okay, and then what happens is you are also having this arm. So this arm basically points out the various sector and points out the various tracks on which your data is being stored. So every arm is having read and write head associated on your platter. So if you are having 8 platters, so there are 8 read and write heads. So these read and write heads actually being pointing out your data on which particular sector you are working on or on which particular track you are speaking of. So this particular read and write head will be actually tracking down all your data which is need to be accessed by the user. Okay. Now what are the various disk scheduling algorithms? So first of all, when we talk about scheduling algorithm, as we have learned in the previous lectures also, scheduling is like you are actually finding out which particular algorithm could be used in order to access the data. So in disk scheduling algorithm, again we are accessing the data but on the disk. So what happens is your operating system is definitely responsible for using hardware very efficiently. That needs to be the very first and major requirement for any hardware, that it needs to be accessed in very efficient manner. So for all the disk drive, it means you need to access all the storage in a very fast pace, or the access time would be very fast, or you can say the bandwidth would be very fast. So the access time, when I'm talking about the access time, it should be consisting of 2 major components. So first of all is the seek time. So seek time is what? It is the time for the disk that you actually think of that your read write arm is switching between one sector to the another sector or switching between one track to the another track. So seek time is the time for the disk that is needs to move the head to the cylinder. What is this? Seek time is to move the heads to the cylinder containing the desired sector. So when you are traveling from one sector to the another sector, so that is the time taken by your head, your read write head. That is the seek time from one point to the another point. What amount of time your read write head is going to take? That is your seek time. Now again next major component is the rotational latency. So rotational latency is, again, that is the additional time. This is the additional time waiting for the disk to rotate the desired sector to the disk head. So this is like, if I am going to talk about, this is the additional time for the disk in being ordered to rotate this particular sector to this particular area. So consider it like my read write head is at sector 4 and I want to move at sector 8. Okay, so what happens is, when you have to move from sector 4 to sector 8, so this is the additional time which is being add upon on your seek time. So rotational latency is the additional time waiting for the disk to rotate. So when I am moving my disk, so the additional time that has been associated with this spindle is that I have to wait for some time, so that my read write head will be starting from sector 4 and will end at sector 8. So that is my rotational latency. And we need to ensure that we should be having minimum seek time. So minimum seek time is only happens when you are having minimum seek distance. So disk bandwidth is basically the total number of bytes transferred divided by the total time between the first request of the service and the completion of the last transfer. So this is what, this is actually when you have to find out what is the bandwidth of the disk, that is the how many number of bytes has been transferred divided by total time between the first request of the service and the last request of the service. So you have to add these two requests and then you have to divide your total number of bytes transferred by this particular addition. Then you will be able to find out the disk bandwidth. Now these are the components that are associated with the disk input output transfer. What is this? First of all, you have to wait for the device. Whenever you are having the device, then what happens is, this would not be the scenario that any time the request has been generated, the device is free and you can able to access at that particular time. So it could be possible that you should wait for the device. So this is that particular time. Then after that, you will be waiting for the channel, that at what kind of algorithm that you are using, what kind of channel you will be going to use. Then additional time for the waiting, that is for the channel. Then your seek time, then your rotational latency, and then your data transfer. So this happens when your device is being accessed by any user request or it is being accessing any kind of a data. So seek time, rotational delay, and the data transfer. These three points are basically you're going to have in your device bandwidth. Okay. Now there are various kinds of disk scheduling algorithms. So first of all, we need to understand what are the various resources or the sources that are going to access our disk. So first of all is our operating system. Definitely operating system must have some kind of algorithms or processes that needs to be accessed from the disk. The data needs to be accessed from the disk, and then that particular process will be executed. So your first one is your OS. The second one is your system processes. Definitely there are various kinds of processes that are associated inside our system that are going to use our disk, and then user processes. So there are basically three major sources that are going to access our disk. Now input output request includes input output mode only. So whenever any kind of input output request has been made, that means you are actually accessing the input and output hardware. So on that case, disk address, memory address, and the number of sectors are need to be transferred. So only on that case you need to have what? Disk address, at which particular sector, which particular track, which particular memory address is being accessed by your hardware, and that hardware is only input and output mode. So OS maintains a queue of request per disk or per device. So your operating system will be going to maintain a queue of all these input and output requests. So it is depending upon what kind of sector you are using, or what kind of you can say request you have, the request has been generated by the user or by the system or by the operating system itself. So it is maintaining a queue for all these requests as per the device which is being transferred, or which is actually using the disk. So the idle disk can immediately work on input output request if your disk is idle, your disk is not being used by another request or not being used by another process, then only it will immediately work on your input output request. Busy disk means work must queue. So if your disk is busy, then your request will be inserted inside the queue, and as per the queue, then your input output request will be accessed. Optimization algorithm only makes sense when a queue exists. So all these disk scheduling algorithm occurs when you are having your queue with it. Your optimization algorithm only occurs when you are having a queue for it. So if you are not having queue, it means your disk is free and you can access your disk immediately whenever there is a request. Okay. Now the disk structure. So the disk drives are, you can say these are one-dimensional arrays, and these one-dimensional arrays are actually the smallest unit of transfer. So these dimensional arrays are basically the logical blocks. So these are the logical blocks which is mapped into the sectors of the disk sequentially. So when I talk about disk structure, so this particular array which is having larger blocks, and these larger blocks are sequentially mapped into your disk. Now sector 0 is the first sector, and the first track is the outermost cylinder. So this is all in a logical form. Your sector 0 is your first sector, and your first track would be your outermost cylinder. So when I am talking about this, consider this as the sector 0. When this is sector 0, so outer side of the cylinder, yani, suppose this is the outer side, this is the outer side. So this is track 1. So this is like this, track 1, then this, track 2, track 3, track 4, track 5, 6, 7 and so on. So this is actually forming a kind of a sector here. So this is sector 0, and the outermost edge is your track 1 here. Okay. Mapping proceed in order through that track, then the rest of the track in that particular cylinder, and then throughout the rest of the cylinders from outermost to the innermost. So your mapping would be like, if I want to say this is sector 4, track 5. So how you will be going to map this? If this is my sector, this is my sector 4. Consider this as your sector 4. Now this is your track 1. Then this particular line is track 2, T2. This is T3 and this is T4. From the outermost side to the innermost side, you are actually mapping your particular section that you want to access. So the mapping proceed in order from the outermost section to the innermost section. Okay. Now the various kinds of disk scheduling algorithms are there. For first of all, obviously we need a queue. The queue must be having some kind of you can say tracks, numbers, sectors, so it would be in numerical form only. And these several algorithms exist in order to serve your disk in an efficient way, or in order to serve your input output request in a much efficient way. So analysis of these disk scheduling algorithm could differ from each another, because one disk scheduling algorithm will be giving you a kind of complexity which is best in some case, but same algorithm will be giving you time complexity or space complexity in a worst case. So these analysis would differ from one algorithm to the another algorithm. So first algorithm will be FCFS. So in FCFS, obviously we will be having a kind of queue. So queue here is this one. Okay, you are having different particular numerals. These numerals is actually showing sector number or a track number. It could be anything, but we need to track each and every numeral. And now what we have is the head. So definitely we need head number where our read and write head has been situated. So currently my read and write head is at 53. So what is this picture now? You are having numbers from 0 to 199. So in particular situation, you must be having your starting point and your ending point, and in between those starting and ending point, you must be having these numerals which are being inserted in your queue. So I am writing like 0, 14, 37, 53, 65. So this is particular numbers that needs to be tracked upon between 0 to 199, and I'll be starting from this number because this is the first come first serve. So first of all, where is my read write head? It is at 53. See, it is at 53. Now starting from 53, because it is first come first serve. So which one will be the earlier one or the first one that needs to be tracked first? So first one is 98. So from 53, I am going towards 98. I tracked down 98, then I stopped. Now what is the next? 183. So from 98, I am again going to 183. I tracked 183 and again switching to another value, that is 37. So for 37, I needs to back forth my read write head. So I'll go to 37 and then so on. Then 122, then 14, then 124, then 65, and then 67. And at 67, I will stop my read and write head. So in this way, our first come first serve algorithm will access my data starting from this particular section to this particular section. So in next video, we will be going to learn about next algorithms which is being associated under this particular name, that is disk scheduling algorithm. Thank you.